Okay, so unit conversions are also known as dimensional analysis or unit analysis or factor labeling, but your author calls them unit conversions, so that's the title I'm going to use here. So it's a super powerful tool, and it helps us convert within a system. So within a system means we're either working in English or metric, and so I'm going to talk now about working maybe within the English system, and maybe we're talking about a dimension of length. And so if we know how feet is related to miles, there's 5,280 feet in a mile. That's a definition. That's an exact thing. We can use unit conversion to convert within that system. And then it helps us also to convert between systems. And so between systems means there's English and there's metric. And there might be a time when we need to convert from inches to meters. And we can't go straight from inches to meters. They're both length, but they're in different systems. And so we're going to go from inch to centimeters because this relationship is exact. And anytime we can use a defined quantity that is exact, that gives us unlimited sig figs, and that's a good thing. But we can go between systems. I can go from inches to centimeters, which means from English to metric, and then use a prefix conversion to continue on in a metric system. And then finally, it can also be used to convert between dimensions. And in this context, what I mean by dimensions is, mass and volume are different things. Mass is how much stuff, and volume is the space the stuff occupies. So mass units might be grams and volume units might be milliliters. But we can use a measured ratio, like maybe a density, to go from a volume in milliliters to the mass of that sample. The density of aluminum is 2.70 grams for every 1 cubic centimeter. And so I can go from volume to mass using this ratio, and this ratio is made from measured things. So it has 1, 2, 3 sig figs. So using measured ratios, and as soon as I said measured, that means limited sig figs. I can go between dimensions. And in this case, the dimensions I'm referring to are volume and mass. Okay, so this is the pattern we're going to do. And it is really, sometimes I have difficulty convincing students to do it my way, but just do it my way. Because I have my calculator. And if I'm asked how many yards is 56.2 feet, I would type in 56.2, and then I would either multiply or divide. Do I multiply or divide?
Divide.
Yeah, I'm going to divide by 3. And I get a number, 18.7333333333 yards. So I can do it if it's really simple and if it's something I'm familiar with. I just do it on my calculator. But what I want you to do is to, we're going to use this simple example and think through the process. And then later, when things aren't as familiar, we're dealing with units that you are not familiar with. You know, here, you know that feet are smaller than yards. So a lot of feet is going to lead to a fewer yards. That's how you need to divide by 3. But there's going to be times when you're going to have to let some conversions that you're not comfortable with, you're going to have to let the units guide you. Okay, so the first thing to do is to underline the given. So there's the given and what you're going to find. And the given will have both a number, and unit. I'm underlining it because I want to identify that's a good starting place. That's the given. And then circle the find. So the question says how many yards? I'm looking for an answer that has units of yards. And the find has just a unit. And then we're going to identify a relationship between feet and yards. 3 feet equals 1 yard. And then we're going to change that equality into a ratio. So it helps to make a roadmap. I underlined feet, that's my starting place. And I'm headed to yard, that's what I circled. And I need the feet to go away. So this equality, 3 feet equals 1 yard. What I'm going to do is divide both sides by 3 feet. And then anything over itself equals 1. And now I have a ratio that came from a definition. So this is exact. It has no limit to the sig figs. Now, why did I do it that way? I could have said 3 feet equals 1 yard and divided both sides by 1 yard. Anything over itself equals 1. I now have a ratio that's equal to 1. Why did I do it this way and not this way? And the answer is because I want the feet to cancel. If I'm starting with feet and I'm headed to yards, I need yards to be in the numerator. So we've changed the equality into a ratio. And my ratio looks like this. 3 feet in the denominator, 1 yard in the numerator, and it's something equal to 1. And we know from math that you can multiply anything by 1. Okay, so I'm going to start with the given, 56.2 feet. And I could write it this way, times, and then plug this ratio in. 1 yard is 3 feet equals, and then I see that feet in the numerator and feet in the denominator cancel. But I'm not going to write it that way because all these parentheses are going to start to get a little bit confusing. So even though I could write it that way, I'm not going to. I'm going to start with the given, 56.2 feet. And I'm going to do something I call train tracks. So, everything, above this line is in the numerator. And this line here is like a couple sets of parentheses separating different values. And I now am going to put my ratio in there. So I have 56.2 as a number, times feet, times yard in the numerator, and 3 times feet in the denominator. And feet are going to cancel. And so I'll divide 56.2 divided by 3, and the units that are left are yards. I know it's super simple, but it'll get more difficult, I promise, don't worry. Okay, so I started with a measured value. My measured value has 1, 2, 3 sig figs. I multiplied by a ratio that is exact because it came from a definition, and it has unlimited sig figs. So right now we're using, there's 2 rules for sig figs. There's the adding subtracting rule, line up the decimals, how far to the right do things go. And there's the multiplying and dividing rule, that's what we're using here. So 3 sig figs times unlimited sig figs, my answer should have 3. It ends in the 7, look to the right. That 3 says leave it a 7, don't round up. And my answer is 18.7 yards. Got a lot on the page, so I'm going to put a box around it. And that would be my length. Normally we'd say what we just solved for. Okay. So here it says how many meters is 56.2 feet. I'm going to underline the given, the thing that has both a number and a unit. I'm going to circle the find. I'm going to identify relationships. Do I know how many meters in a foot or how many feet in a meter? Maybe not. So there are some relationships you'll know. Do you know how many feet are in a mile? Okay, so I'm going to start with my roadmap. Because I underlined 56.2 feet, I'm starting with feet, that's the given, and I'm headed to meters, and I don't know one relationship. I do know how many inches are in a foot. And I do know how many centimeters equals an inch. We just looked at that on the other page, and I know what centi means. So here I have 3 arrows in my roadmap. I'm going to go from large English units to smaller English units to an even smaller metric unit, and then back up to a larger unit. But the important thing is, if I started with English on the left, and I'm talking about length, and I have metric on the right, then I need to have my inches to centimeters conversion in the center, and the inches go on the left because I have the English unit as a starting place. Okay, so now we're going to identify relationships. How many, I need something here. Well, I know that there are 12 inches in a foot. And I could write that as 1 foot is 12 inches.
12 inches over a foot.
Yeah, why?
Because you want to cancel the inches.
I want to cancel the feet? Yes, and I want inches to be on the top. I knew what you were thinking. We're good. Okay, how about between inches and centimeters? Do I know a relationship? Yes. 2.54 centimeters is 1 inch, or an inch is 2.54 centimeters. Sometimes people will say 2.54 inches is a centimeter, and that's not true. So right now with your fingers, you're at home, nobody's looking, make the distance between your fingers that you think is about 1 inch. And then look at the width of one of your fingers. That's a centimeter. So because centimeters are smaller than inches, it takes a couple centimeters and a little more to get to an inch. Okay, which one of these do I want to use? The one on the left or the one on the right?
The one on the left.
Why?
So that you can cancel.
So inches cancel, because they're in the bottom, and centimeters are in the numerator? Yes, yes, and yes. Okay, one more conversion factor between centimeters and meters. So there was a prefix practice page that I hope that you did. I don't know if you did it. And it had things like this. There were 3 ways to do it, and one of them was wrong. Okay, so one thing we can do is recognize what centi means. Centi means 10 to the negative 2, or 1 over 10 to the 2, or 1 over 100, or 0.01. All of those mean 100th centi. Okay, so it takes 100 hundredth meters to add up to a whole meter. That's one way to approach it. It takes a whole bunch of these small things to equal the larger thing. Or I could say 1 centimeter means 1 centimeter. The way to do it that is wrong is to put the meaning of the prefix in front of the prefix. Because now I said 100th of 100th meter. So 100 hundredth meters equals a meter. Or a meter is 100 hundredth meters. Alrighty, so I have changed my qualities into ratios, and now we can make our train tracks. Because I have 3 arrows, 1, 2, 3, I'm going to need to have, so here's my given, 56.2 feet, a conversion factor here, and here, and here, and then we have an equal sign. Alrighty, so feet cancel feet, inches cancel inches, centimeters cancel centimeters, and we only have meters. Calculator, anything that's in the numerator, I'm going to multiply by, and anything that's in the denominator, I'm going to divide by. 17.12976 meters, round to 3 sig figs, 17.1 meters is our answer. Okay, so keeping track of sig figs, the measured value, the starting place, always has a limited number of sig figs. Many times, the number of sig figs in the final answer equals the number of sig figs in the starting place. If the ratio comes from a definition, unlimited sig figs, and so I mean inequality, where if we divide both sides by 1/2, one of the sides, we get something equal to 1. That's unlimited. But if the ratio comes from a measured value, we have to consider the limited sig figs. What kind of things will be measured? For today, it's going to be if we have a rate, some change per time, or if we have a density, those are measured. So usually the terms in the middle aren't changing the number of sig figs. We will see this twice today. So if you're not sure, just whatever sig figs you started with, round to that number in the end. Okay, and so we begin. How many feet are 359 yards? I'm starting with yards. I'm headed to feet. Do we know a relationship? Can we do that in one step? Yes, 3 feet in a yard. I need yards to cancel, so I put it on the bottom. I put 3 feet on the top. Yards cancel, and the units were left with our feet. How many sig figs should I have? This has unlimited because it's exact. Exact means there's no uncertainty. So our answer is going to have 3. 1, 2, 3. Look to the right, side hat around. This one may be different than on the handout. I don't think it was 359 yards. I think I mistyped it. Okay, so I have an answer here, 1080. We're rounding up because the 7 is, greater than 5. But this answer is ambiguous because what I'm trying to say is 3 sig figs, but I can't tell. There's 4 digits there. And anytime we have a whole number that ends in 0, we have to ask ourselves, is that significant? I don't know. So how do we clear up any ambiguity?
Scientific notation.
Ah, yes. So my calculator can do that for me. I'm going to type in 1080 and hit second function 5. And I see that it's 1.08 times 10 to the 3. Or I can say the decimal was here. Let me go over 1, 2, 3 spaces, which means the power is 3. Calculator can't count sig figs for me, so I have to do that myself, but it can help me get from expanded notation into scientific notation.
You said you hit second and then what?
Second function on this calculator, which I recommended you buy, I hit second function 5, puts it in scientific notation, and second function 4 puts it back into expanded notation.
Oh, okay.
Okay, how many inches in 2.9 yards? We're starting with yards. We're headed to inches.
I came up with 104.4 inches.
That sounds right. Good.
But I'm not.
Are you going to put a box around that? Is that your final answer? No, you need to round it. How many sig figs?
2.
Good. 1, 2. Look to the right. Leave that 0 as 0. There. Is that the right answer? No.
No.
10 is much smaller than 100. So we need to put a placeholder in here. So 104 to 2 sig figs rounds to 100. But now it's ambiguous. What are you going to do?
Put it in scientific notation.
There we go.
Bingo. Yep, that's it. What's my exponent?
2.
2.
Good. So I've written it 2 ways. Some people prefer like a bunch of these small things. And then some people prefer to say, I'm going to use the meaning of the prefix in place of the prefix. Whichever way you prefer is totally fine. These are both right. But if I had, for example, instead of having the 100 down there, if I had it up here, that would be wrong. And if I had the 10 to the negative 2 down here next to the meaning of the prefix, that would be wrong. Okay, so I want to have us put both of them in our calculator just to practice it. So, you know, there's different ways you can do this. So for the one on top, I'm going to put in 49.6 times 2.54, divide, and then I want you to learn where your EE or your EXP key is. So I want you to put in 1 EE2 equals. And I got 1.25984. Inches cancel, centimeters cancel, we'll just meters. So let's go ahead and practice that just for a second. Type in 1 EE2 equals, and then change it to second function 4 to flow so that you can see that those are equivalent. So EE just means times 10 to the. On a different calculator, you might be using something called EXP. And it's understood to be a base 10 exponent, and let that be 2. It doesn't really matter if there's not a lot of zeros. You know, 100 doesn't have a lot of zeros. But when you're dealing with something like 10 to the negative 9, you're going to need that EE key. Okay, so for the second one, this time it's in the numerator. And we're going to put in 1 EE negative 2. So 49.6 times 2.54 times, because it's in the numerator, 1 EE, and then my change sign key is down here on the bottom. And I get the same answer. So we're proving to ourselves that math works. And you may be thinking, well, I have it working one way. Like, why do I have to do it both ways? And the answer is because there may be a day in this class when it's easier to do it the other way. So you're going to want to know how to use your calculator on that day. Okay, how many sig figs should my answer have?
3.
3.
I'm going from miles, which is length in the English system, to meters, which is length in the metric system. I have to go through centimeters to inches. Which side do I put centimeters on?
Right?
Right.
Oh, wait.
Why? No, right's what? Right.
Okay.
That's why.
Because you have to convert, I want to say miles into feet and then feet
Yeah.
into inches.
Yep, you got it. So let's say that you weren't thinking ahead like that and you wanted to put centimeters here and inches there. At some point you're going to go, whoa, hold on. Those are one system. These are the other system. That doesn't make sense. So the place where we're crossing over from English to metric, we only want to cross over once, is right here. How many feet are there in a mile? Okay, seconds to hours. I don't know what happened to my font size there. So starting with hours, I suggest you go 3 minutes. I have had people tell me that there's 60 seconds in an hour, and that's not true. So you can do this unit conversion thing in both the numerator and the denominator. And so that's what we're going to do here. We're given a starting place of 65.2, and MPH stands for?
Miles per hour.
Yeah. So every 1 hour at this rate, we're going to go 65.2 miles. So we have 2 conversions, one in the numerator and one in the denominator. In the denominator, we're headed to seconds. And in the numerator, we're headed to meters. So it is a little bit confusing because here, this M means miles, but we're just used to that. MPH is miles per hour. And here, the M means meters. MPH is miles per hour, but N normally means meters. And unfortunately, in chemistry, there's a lot of M's in science. So this is a lowercase m. Okay, so in the numerator, we're going to go miles to meters. And in the denominator, we're going to go hours to seconds. So how many conversions do I need? How many arrows do I have? 6. And it doesn't matter what order you do things in, but I'm going to need 6 places for things. 1, 2, 3, 4, 5, 6 equals.
It's only night.
Miles cancel miles, feet cancel feet, inches cancel inches, centimeters and centimeters. I'm left with meters on top. That's good. Hours cancel hours, minutes cancel minutes, and I'm left with seconds on the bottom. So I know that I've set up my ratios correctly. I didn't flip anything because the units work out. Now, when you put this in your calculator, the way I like to do it is just sweep. So I would put in 65.2, and then I would divide by 60, multiply by 5,280, multiply by 12, multiply by 2.54, and then finally divide by 100, hit equals. And just hit equals once. Sometimes students want to do all the numerator and all the denominator and then divide, but I've seen students set it up correctly and get the wrong answer doing it that way. So I wouldn't recommend that way. I like to sweep, just go from left to right. And if it's in the numerator, multiply, and if it's in the denominator, divide. But some students prefer to do all multiplying before they do all dividing. So now I'm going to walk through the numbers with that path. You could have 65.2 times 5,280 times 12 times 2.54, divide by 60, divide by 60, divide by 100 equals. Just make sure that everything in the denominator, you're dividing. And I got 29.1. Did you get that?
Yes.
Yeah.
And this would be a rate. Or maybe this rate, because it's length per time, we could call it speed. And if we knew what direction that speed was in, we'd call it a velocity.
Close the door.
Questions? Okay. So this one is quarts to liters, and those are both volumes. And we need something to get us from quarts to liters. So I have memorized, or it's on that page that you have, 1.06 quarts is a liter. But if I was to divide both sides by 1.06, I would get this. So those are both true. I prefer to memorize this one because it's easier. I know 1.06, but sometimes I forget what side does that go on. And then I remember the English system is so weird. You know, 4 cups, 2 cups in a quart, 4 gallons. I don't know. There's 2s, 4s, 16s. And if we're going to have a weird number, it's going to go with the English one. Metric is very like 1, 10, 100, base 10. So how this many quarts is how many liters. Okay, so this one is different from some that we've been doing. We're starting with the measured value, and the measured value has 3 sig figs. But this relationship, because it goes, even though it's the dimension of volume, it goes between English and metric. It is limited in its sig figs. So if we only had a value here that was good to 2 sig figs, our answer could only have 2 sig figs. Is it always 1.06 quarts as a liter? No, to 4 sig figs, it's 1.063 quarts as a liter. So they measured quarts and for the same volume into something that can measure liters, and so those are measured values. This is an example of a conversion factor that is limited in its sig figs. Why? Because to come up with it, measurements were made. It wasn't defined. How many sig figs did we start with?
3.
4.
2.
2.
Yeah,
Oh, 2.
placeholder.
Mommy, look at me.
So there's a couple ways that we can make this number, which is now ambiguous, not ambiguous. One would be change to liters, except we were asked to give it in milliliters, so we're going to have to use scientific notation. But just so you know, metric prefixes and scientific notation, they both serve kind of the same purpose. Which one do we do? Whatever's convenient or whatever's asked for.
Is it 2 since the 2 zeros on the left don't count?
Right. So this is by convention to say there's a decimal coming up, watch out. And then this is a placeholder. It is necessary because if it wasn't there, our number, 83, would be 10 times larger.
Okay.
So necessary, but not significant. Placeholders are necessary, but not significant. Significant means measured and the one estimated one. Okay, so now we're looking at a conversion that's sort of in the same system. So kilograms is mass and pounds is force. And the way that mass and force are connected is through the gravitational pull. So the mass is related to the force by a constant of gravity. And since gravity is pretty much the same everywhere, we treat them like they're the same kind of idea. They're not quite the same kind of idea. But you may have learned 2.2 pounds is a kilogram. I only know that the 2.2 goes with pounds. This is the one I've memorized, is because, you know, pounds is English, and of course they would have a weird number in front of it. That's how our system is. And the other thing is, I prefer to see my weight in kilograms. It's a much smaller number. So I know the 2.2 goes on that side. but it's really, it could be to 3 sig figs, 2.21, or to 4 sig figs, 2.206, I believe is the answer.
205.
Oh, is it 5? Thank you.
Yeah.
Handy having you around. So some people memorize it that way. But when you go in a grocery store, you'll see things that are like 1 pound is 454 grams. Same idea. And this 454 could really be 453.6. So it doesn't matter which one you use. You just want to pick one that you're comfortable with and realize that this is getting us from English to metric. Now let's say I had chosen to use this conversion. So I'm starting with 3 sig figs. I can only report my answer to 2 sig figs. Because these are all limited in their sig figs. This was the measured starting place, 3 sig figs. This was a conversion factor that only had 2 sig figs. Why did I suspect it wasn't exact? Because it goes from English to metric. The only one that's exact between systems is the centimeters to inches one. Okay, this one is different because we're dealing with something that isn't one-dimensional. A length is one-dimensional. An area would be two-dimensional. A volume is three-dimensional. But this two-dimensional square foot idea means we're going to have to do a conversion twice, and there's a shortcut way to do that. Let's see. So I'm starting with 18.4 square feet. And what that means is 18.4 feet times feet. The only thing that is squared is the units. And what that means is, oops, pretend that's a straight line, that we have a square, that this area inside of here would have been 18.4 square feet. So square foot, square foot, square foot, square foot, square foot, square foot, square foot. And there would be 18.4 of those present. So that's a measured number, and it's 3 sig figs. And the thing that is squared is the units. And now we're headed to meters squared. So one way to look at this is I'm headed from feet times feet to meters times meters. Now, if I was doing this one-dimensionally, I would go feet to inches to centimeters to meters. Same path, but we're going to have to do every step twice. So 1 foot is 12 inches. That takes care of one of the feet, but it doesn't take care of both of them. We have to do it a second time.
I have a quick question.
Yeah,
Why couldn't you just do it all to the second?
we're going to in a
Okay.
second. But for some people, they're going to want to see it this way first. But yes,
Gotcha.
yeah. Okay, so now I'm going to do feet to inches. Oh no, inches to centimeters. I didn't see who was saying that. They were on my other grid page.
Is Sam.
Was it you, Sam? Yeah, I thought maybe. Okay, but Sam has a good point. That's a lot to write. And here's a way to do that shorthand. So you know how multiplying is just adding shorthand? Squaring is just multiplying shorthand. And so I'm going to use my conversion that gets me from feet to inches. And instead of doing it twice, I'm going to square it. Just make sure that you're remembering that you're squaring everything inside the parentheses. Okay, so now we're going to do that same idea, except it's a volume. We're taking a length times a width times a height to come up with the volume of a fish tank. And then to get to liters, we're going to take our inches cubed and go to centimeters cubed. So that's the place where we have to cube the inches, the centimeters to inches conversion. But then a centimeter cube is a milliliter. So there's no cubing of the milliliter. And then we use the prefix to get to liters. Okay, so how to do this on your calculator. On my calculator, I have a little key that says y to the x. And so I'm going to type in all of that times 8 times 10. And then I have a number. Now I'm going to say times 2.54 y to the x 3. And that takes care of all of this. Or you can just use the caret, but sometimes you're going to need the y to the x. That'll be important at some point. So you could say times and then 2.54 caret 3. But I recommend this way. How many sig figs will my answer have?
2.
Yes. Because of that. So just for fun, we're going to use a set of antiquated British units. And they're all liquid units. So what that means is we're converting from one kind of liquid unit to another kind of liquid unit within the British set. So all of these are exact, unlimited sig figs. The only thing that has limited sig figs is the starting place. So that has 3 sig figs. So we're going to go from hogshead, and we want to end up with tons. And I don't need all of these. The only one that has hogshead in it is this one. So I'm going to have to go from hogshead to firkin. I don't have a choice, whatever that means. And then the only one that has firkin in it is this one. And then I see, oh, I can get from pottle to ton. So this one was extraneous.
So this one is just more give you the information and figure it out.
Yep. It's really highlighting a couple things about the process, which is even if you have no idea what the units are, you can use the units to answer the question. There is one more reason I like this problem. It's not that I love 36 so much. It's just that's not the right sig figs. We're not done. So it highlights the point that my calculator can't do sig figs. Even though I landed on a whole number, that's not the correct answer. I have to add a 0. Why? Because I started with 3 sig figs. Okay, so these are the last two. There are times that the conversion factor is limited in its sig figs. When is that? We saw it when we were going from liquid to liquid, like a volume to a volume, but one was English and one was metric. So when you go between systems, those are not exact. The only one that is centimeters to inches. But when you have something that's measured, density and a rate, those are measured things, those limit sig figs. So here we have information about a density. The question gives us a number plus units, that's the starting place. And asks for a mass. What kind of units are mass units?
Grams.
So we're headed to grams. So I want to go from centimeters cubed to grams. How do I do that? Well, I need the centimeters cubed to cancel. And here I have a relationship that shows me how many grams in 1 cubic centimeter. So we're using density as a conversion factor. Centimeters cubed cancels. I'm left with grams. 2 sig figs times 3 sig figs. So when we're going from volume to mass, or from mass to volume, we're going to use density. Okay, so we're going to do that same idea now, but instead of going from volume to mass, we're going from mass to volume. So 25 grams. And we want to end up with volume, so cubic centimeters would work. So now I'm plugging density in upside down. So it's the same ratio, it's just flipped. We say we're using the reciprocal. Why? So the units cancel. Two sig figs, 3 sig figs. My answer should have 2. 9.3 cubic centimeters. It was 9.259259,259,259. And so some people would say, if you look to the right, you see a 5, round to even, and the correct answer should be 9.2 centimeters cubed. I mentioned this in one of the videos before. I honestly don't care if when you see a 5, you round to even or not. Okay, and the last one is using rate as a conversion factor. So rates are also things that are measured that get us from one kind of thing to time, or from time to a different dimension. And so here we have a pump that can remove water at a rate of 0.026 liters per second. So we can go from volume to time, or from time to volume using this rate. In one direction, we're multiplying, and in the other direction, we're dividing. Okay, how long will it take in minutes? So we went ahead to time in minutes. And then we have some dimensions like a fish tank. So cubic centimeters are our starting point.
Okay.
because the rate as a conversion factor has limited sig figs. So here, 40.0, this 0 is after a decimal and a non-zero digit. And that means it's significant. Okay, to summarize, when using unit conversions to solve a problem, you must show your work. There is going to be a time when it isn't just multiple choice, and I'm going to ask you all to submit through, there's a submit button in Canvas, like to take a picture with your phone and to send me the picture of your work, and I'm going to need to see those train tracks. Conversions within a system are defined, which means you don't need to worry about sig figs, they're unlimited. Within a system just means all metric or all English. Conversions between systems are limited in their sig figs, except for this one, and it is so weird. Why that one? I don't know. That's the only metric to English conversion that is exact. And then density is used to relate volume to mass and mass to volume, and it has limited sig figs. And rates, which is just something per time, is used to relate different dimensions to time. In our example, it was a volume to time. Earlier, when we talked about miles per hour, it was a length to time, but rates are just something per time. All righty, that's everything. You did great. Congratulations. You stuck with it.